Hello, thank you for watching this video. So in this video, I'll be doing question 6 of November 2024, question paper mathematics paper 2. And the topic is trigonometry. So we're still continuing with trigonometric principles, right? So before I even start, let me pass on this message. So if you want to attend our online classes, you can see our contact information on the description below. You can contact us or read more on the description and see if you are happy with our rates. If you are, you can contact us, then we can work from there. So, but let's continue. They are saying we are given that the identity cos x minus y is equal to cos x times cos y plus sin x times sin y. So we are given this identity here, right? No problem. It's 6.1.1. They're saying use the compound angle identity given above to derive the formula for cos x plus y. So they want us to use this compound angle identity that we have here to derive cos x plus y, right? They want us to find the value of this, which is, let's find its own formula, actually, using the formula of this using this one up here. So if you're looking at this, in order to be able to use this, you must try to write this so that it looks similar to that. So you want to have the x, which you have. You want to have minus, which you don't have. So you're trying to find the minus, but at the same time, it should be equal to this. So how do we do that? So you can say, okay, this is equal to cos what? X, which is that, which is this, fine. You want to have a minus, so here's your minus. Right? After having that minus, now you're able to apply this formula. But you also need this y here. But if I put the y here, this is exactly that. And this is not equal to this. But if my y can be negative, see, if my y could be negative here, this times this would be positive. So, in this case here, I can use this formula up here and say my x is x, the minus is minus, and my y there is minus y here. So, I can be able now to use this formula because this have the same shape as that. So in that case, I can say, okay, my cos x minus negative y is equal to what? It's going to be equal to what? Cos x, right? Cos x times cos y, but my y is this part here, so it's going to be cos negative y, right? Plus what? Plus sin x, which is sin x phi, times what? Times sin y. But my y is this minus y here, times sin negative y. So, in that case, this is simplified, this is not simplified. This is simplified and this is not simplified. So, like I said in the previous question, if you have, let me do this. Let's say we have 0, 90, 180, 270, and 360. So angles that are here are acute angles. They are less than 90, but more than 0. So if you subtract an acute angle from 90, it will be on the first quadrant. So if you say 90 minus an acute angle, it will be here. If you say 90 plus an acute angle, it will fall on this side. If you say 180 subtract an acute angle, it will fall on this side. Right? And if you say 180 plus an acute angle, it will be here. On this 270, if you subtract an acute angle, which is an angle that is between 90 and between 0 and 90, it will be on this quadrant. If you add an acute angle, it will be here. And on this 360, if you subtract an acute angle, it will be here. You should subtract it. Fine. Remember that on the first quadrant, your sine theta, your cos theta, and your tan theta are all positive. Here on the second quadrant, only sine theta is positive, right? Here on the third quadrant, only your tangent of theta is positive, right? And here, the tangent, should be the cosine maybe, of theta is positive. That makes sense. So, cos, all functions are positive here. Sine is positive, tan is positive, and cos is positive here. Fine. So if you have an angle, your cos x, because I'm assuming that x is positive, right? So if x is positive, I can think of x as an acute angle to be here. It's theta. But this is negative, right? I have negative y, and I do not have anything negative here. So like I said when I was doing question 5, if you have something negative here, a negative angle here, negative angle, you add 360 to it so it becomes positive, right? So what we will have here, we'll have that our cos x plus y, because this is cos x plus y, is equal to cos x times cos negative y. But this is negative, so you add 360 to it for it to become positive. If it was more than 360, you're going to subtract the 360 so that it comes back on this interval there. So you add 360 here, you'll have 360 minus y, right? Fine. Plus sine x, which is okay, times what? This is negative, the angle there. So you add 360 to it. So to be sine 360 minus y. Fine. In that case, the cos x is okay, simplified. Now you need to simplify this into an acute angle. Where is 360 minus? 360 minus is on the fourth quadrant. Fine. How is cos on that quadrant? Cos, you can see on the fourth quadrant, where 360 minus is sitting, is positive. So what you'll have, you'll just be left with cos of that angle, which is cos of y. Plus what? Plus sine x, of course, times. Where is 360 minus? 360 minus is on the fourth quadrant. Fine, you can see the fourth quadrant. Fine. How is sine there? What is this? The sine for your sine function there, or sine trig ratio there. Your sine on the fourth quadrant is negative because only cos is positive here. Sine is negative, positive there and there. So your sine is negative there. So times negative sine of that angle there. Wow. So if you simplify this, you get that your cos x plus y is equal to cos x times cos y. This times this, it will be negative sine x times sine y. So this is your cos x plus y using this thing over here. And we're done with 6.1. Okay, so now we're doing 6.1.2. At 6.1.2, they're saying, hence or otherwise show that this thing here is equal to this thing, which means they wanted to show that the left hand side is equal to the right hand side. Right? No problem. So, when you're given this, something like this, they wanted to show an identity. You are proving an identity here. So, one thing that you need to keep in mind is that it's easier to always use the much more complex, or to simplify the complex one to make it simple, right? So in this case, I'm going to choose the left-hand side, right? I'm going to work with the left-hand side because the left-hand side is complex, so there's a lot to do here. But the left-hand side is simplified to its simplest form, so there's nothing much you can do with it. Okay, so even though you're working with the complex left-hand side, you need to look at each of these things individually, like one by one, to simplify each and every one of them. You can't simplify the entire thing and look at it as a whole. Look at this, look at this, look at this, look at this, same to all of those. Then, once you do that, you should be fine. Fine. So if we're looking at this, if we are trying to simplify these, right, you must ask yourself maybe 3 questions, right? Question number 1, where is the angle? Which means I'm asking the quadrant, which quadrant is your angle? That's question number 1. Question number 2, what do we say? So what is the sign of your trig ratio? Trig ratio there. When you say trig ratio, talk about your sine, your cos, or your tan. That's what you're talking about. You're asking the sign of a trig ratio. And the third, you ask where, actually, third question is the maximum on the vertical or horizontal line. Right? So, what you need to know also, if your maximum is on horizontal, if you have a horizontal maximum, what happened? Ratio, your trig ratio do not change. Do not change. If your maximum is on the vertical, which is a vertical maximum, the trig ratio changes. This is what you need to understand in order to be able to prove identities or simplify trig expressions. So if you understand these, you'll be able to do all sort of trig ratios or simplify all trig expressions. So let's go. Let's come to this one here. So I don't have space, I'll write over there. Your first question is, where is 90 minus? 90 minus is on the first quadrant, right? So this is the first quadrant, this is the second, this is the third, and this is the fourth. So, where is 90 minus? 90 minus is on the first quadrant. That is the first question. I'm asking, where is the angle? The angle is what is here. Where is 90 minus? Which is which quadrant? It's on the first quadrant. That's the first question. You go to the second question. You ask yourself, what is the sign of your trig ratio there? What is trig ratio? When you talk about trig ratio, to speak about sine, cos, or a tan. Your trig ratio in this case is cos, which means what is the sign of your cos on the first quadrant? On the first quadrant, all of these ratios are positive. All of the trig ratios are positive, which means the sign of your cos is what? Is positive. So what do? You say, okay, I have a positive sign, right? So it's positive sign, right? You're done with the sign question. Third question, you're asking your maximum. Is the maximum on the vertical line or on the horizontal line? What is the maximum? The maximum is this number that is sitting over here. So is this number here on the vertical line, this 90 degrees, is it on the vertical line or on the horizontal line? So you can see 90 is up there, so it's on this vertical line here. So if your maximum lies on this vertical line, which is 90 or 270, or any other thing that lies on the vertical line, your function will change to its co-function identity. For example, if you have cos x, or let's say if you have cos, it will change and become sine. If you have sine, it will change and become cos. So cos and sine are trigonometric co-identities. Right? No problem. So, first question, we ask ourselves, where is 90 minus? We said 90 minus on the first quadrant. Second question, what is the sign of the trig ratio? What is the sign of that cos on the first quadrant? We agree that the cos is positive as well, because all of them are positive on the first quadrant. Fine. Third question, is the maximum on the horizontal line or the vertical line? We agree that 9 is on this vertical line here. So now, if it's on the vertical line, if your maximum is on the vertical line, right, your trig ratio will change, which means your cos will become sine and sine will become cos, which means, what did we have? We had cos there. So if we had cos, it will become sine. Sine of what? You just take the sine of this angle that is sitting there, of that angle x. So what you have here, you have sine x. That's what you have. So you have positive sine x. 5. Cos y is already in a simplest form. It's already simplified. So you don't have to do anything there. So you just say cos y, right? Plus sine minus x. Oh, sorry, sine minus y. Where is minus y? If you look here, there's nothing about minus y. So, I'm assuming your x's and y's are positive, right? If you have a negative angle, add 360 to it so that it appears here. So that it appears as one of these things that you can see over here. Because I know where minus y is. If you know it, that's good. But I'm thinking of a student who might not know what this thing means. If you see a negative angle, add 360 to it until it becomes positive. So what you have your sine, right? Of what? Of 360 minus y, which is you added 360 here. That's what we did. Times what? Times cos 180 plus x. Times cos 180 plus x. So this, you apply the same rules as there, because you just want this to be just cosine of angle or just, yes, that's all you need to do. So ask yourself, question number 1, where is 180 plus? 180 plus is on the third quadrant, you can see. That's question number 1. Fine. What is the sign of your trig ratio on that quadrant? Which means you are talking about cos on the third quadrant. Go and look for cos. On this quadrant, only tan is positive, which means your cos is what? Your cos is negative. So you just put the sign for your cos there. Put negative. Fine. We're done with the sign part. We move on. Is the maximum on the horizontal or on the vertical line? Your maximum here is 180. Go and look for 180 there. 180 is on this horizontal line. So I said, if the maximum is along the horizontal line, your function will remain the same. Your function do not change. If your maximum is on the horizontal, your trig function does not change. So in this case, you just have negative cos of whatever the angle was there, which is cos x. All over what? Cos x, no problem, we don't have to do anything there. 360 plus, where is 360 plus? I don't see any 360 plus here. I don't see any 360 plus here. So what do we do? I like working with numbers, with angles, or let's say with angles, it's an angle, right? That are from 0 degrees to 360 degrees. So those are the angles that I'm comfortable working with. So in this case, what do we have? We have 360 minus, so which means, or we have 360 plus y. If your angle is above your 360, subtract 360 to it until it falls back on this. This was less than 0. You added 360 so that it comes up here. But now, this one is above 360. You subtract 360 so that it comes back. So in that case, what do we have? And times cos 360 minus 360, right? Plus y. Plus 360 minus. Where is 360 minus? 360 minus is on the fourth quadrant. What is the sign of your sign there? On the fourth quadrant, only cos is positive. The others are negative, so it's negative. So, third question is our maximum on the horizontal line or on the vertical line? 360 is on the horizontal. So the sign will not change. You just take the sign of this angle here. Sine of angle x times sine of angle y. So in that case, simplify. Positive times the positive, so we have sine x times cos y, right? Plus. In this case, we still have this to resolve. Where is 360 minus? 360 minus on the fourth quadrant. What is the sign of sine? That sign is negative. So you have negative, right? So where is your maximum? Is it on the horizontal or on the vertical? It's on the horizontal. So the function will not change. So you just take the sign of x. Sorry, sign of y. So you have just a sign of that. Times negative cos x all over what? All over cos x times this and this go away. Just left with cos y there. Alright? Negative times negative times this, so this times this is going to be negative. So this times this negative. So you have negative sine x sine y. That's what you have. So let's go and simplify the top again. So at the top you have what? You have sine x times cos y. This times this is going to be positive. So you have plus sine x cos y, right? All over what? All over cos x times cos y minus sine x times sine y. So if you look at this, this is a compound angle, right? And you know very well that your sine A plus B is equal to sine A times sine A times cos B, right? Plus sine B times cos A. And if it's negative here, it will be negative there as well, right? And you know that from these are identities, they're at the back of the question paper. You know that cos A minus B is equal to what? It's going to be it's going to be cos A times cos B plus sine A times sine B. So if it's plus here, it's going to be minus here. So if you look at this, sine A, wait, something is not right. Something is not right. So this should be sine y here. So it should be sine y here, and then it should be cos x here. So if you're looking at this, you have sine x cos y, sine y cos x. So what does this look like? It looks like sine A plus B, because if you look at sine A, you have sine A cos B, sine A cos B, sine B cos A. So if you're looking at this, you're looking at something similar to the top one. So which means you have sine of what? Of x plus y. All over what? All over cos x cos y minus sine x sine y. And this looks like the minus one. It looks like the bottom one, which is you have cos A plus B. Because if you have a negative sign, so it's cos A plus B. So you have over cos x plus y. So this is equal to the tangent of x plus y. So this is how you do this. Just follow those rules. Because you know the reason you're saying, you know sine over cos is equal to tan. So if you sine x over cos, if sine x plus y over cos x plus y is going to be tan x plus y. And we're done with this question. Okay, so now we're doing 6.2, right? So they are saying in 6.2, it is given that f of x is equal to the square root of 6 sine squared x minus 11 cos 90 plus x plus 7, right? So we are given that f of x is equal to the square root of 6 sine squared x minus 11 cos 90 plus x plus 7. Fine. They want you to solve for x in the interval between 0 and 360. If f of x is equal to 2. So we're given that f of x is equal to 2, right? So they want you to solve for x is between 0 and 360. No problem. This is not a problem. So what do? So we're given that f of x is equal to 2, right? Which is the same, equal to that as well. 6 sine squared x minus 11 cos 90 plus x plus 7. So this is equal to what? Let's first simplify this part here first. This is equal to 6 sine squared x minus 11. Where is 90 plus? 90 plus on the second quadrant, right? What sign is cos on the second quadrant? Only sign is positive. So the cos is negative. So you have a negative sign there. Where is this maximum? This maximum is on this vertical line. So I said in the previous question, if your maximum is on the vertical line, your function will change to a co-function. If it's sine, it will become cos. If it's cos, it will become sine. This case with cos, so we'll just have sine what? Sine of x plus 7. So your f of x is equal to what now? It's equal to the square root of 6 sine squared x plus 11 sine x plus 7. This is what you have. Right? This is what we have. So they want us to solve for x on this interval. If your f of x is equal to 2, which is, this is 2 here. So you have 2 is equal to 6 sine squared x plus 11 sine x plus 7, right? This is all under a root, of course. So, this doesn't look very nice, you know. So what we can do, we can say, let's allow our sine x to be equal to k. So if you can do this, we have 2 is equal to the square root of what? Square root of 6k squared, because this is sine, so it's k, so it's k squared, plus 11k plus 7. Right? This looks similar now. This looks like question 1. So you square both sides. What do you have? So this and that go away. So this will be 4. So we have 4 is equal to 6k squared plus 11k plus 7. Solve for k. 0 is equal to 6k squared plus 11k and minus plus 3, because it will be 7 minus 4, 3. So we can try to factorize this thing here. Let's say we have maybe 2x, 2k, or you can use a quadratic from here. 2k and 3k, right? And let's say we have 3 and 1. So both of them are positive. Use your quadratic if you cannot factorize. This times this is 6k squared. This times this is 3. This times this is 2k. This times this is 9k. If you add them, they give you 11k, which is what we have. So these are your factors here. So your factors for this thing is 2k, 2k plus 3, and what? 3k plus 1 is equal to 0. So in that case, your 2k plus 1 plus 3 is equal to 0, or your 3k plus 1 is equal to 0, which is your k, your 2k is equal to minus 3 divided by 2 divided by 2. Your k is equal to minus 3 over 2, or your 3k plus 3k is equal to minus 1. So your k is equal to minus 1 over 3 if you divide by 3 both sides. So what is your k? You wanted to find x. So your k is equal to sine x. So sine x is equal to minus 3 over 2, or your sine x is equal to minus 1 over 3. If you think about sine x is this function here. You should know at least this is the basic one. 0, say 90, 180, 270, and 360. So 90, 180, this is 270, and this is 360. So this is minus 1, and this is 1. So your sine of 90 is 1, 0, minus 1, and 360. It's a graph similar to this one here. Something similar to this. You see that your sine x, the range which is the y value that sine x uses, are between minus 1 and 1. So your sine x is less or equal to 1, but greater or equal to minus 1. So it doesn't go above 1 or below 1 if the amplitude is 1. So you can see here, this is equal to minus 1.5. So your sine x is equal to minus 1.5, which means it went below minus 1, which is not possible because we know sine x is between minus 1, and 1 is from minus 1 to 1. So it is the y values that are from minus 1 to 1. So if you're saying your sine x equal to minus 1.5, this cannot happen. But this is equal to negative 0.33 and so on. So this at least is between there. So this one is possible over here. Right? So we can continue with this one. This we can't do anything with it because it falls outside the boundaries of sine. So it will not work anyway. So let's work with this one. So what we need the reference angle. It's going to be arc sine 1 over 3. Not the negative 1 over 3, just 1 over 3. So our reference angle is equal to the answer to this. What is the answer to this? With our calculator. Let's say arc sine 1 over 3 equal to 19.47. Equal to 19.47. So this is our reference angle. So this is the angle that we're going to use to find our solutions for x. Fine. Where are these solutions of x sitting? They are sitting in quadrants. The solutions of x are sitting in a quadrant where sine is negative. Which quadrant are these? So sine is positive, negative, and negative. So your solutions are sitting where your sine x is negative, which is here and there. So your solution that is on the third quadrant, it will be 180 plus your reference angle, which is 180 plus alpha, plus your reference angle. And the other one, it will be 360 minus your reference angle. So your solutions, the one that will be on the third quadrant, will be x is equal to 180 plus 19.47. And the one that is on the fourth quadrant is equal to x is equal to 360, because that's what you're doing here. Minus 19.47. So the answer to these will be the values of x, in my opinion. Right? So let's find the values of x. So it's going to be 180 plus 19.47. So it's 199.47. And then the other one will be 360. Right? Minus 19.47. And it's 340.53 degrees. That's what I'm getting. So this is how I would have done this one. And I'm done with 6.2. Now I'm going to move to the last one, which is 6.3. So I'm going to clean the board and we're going to do 6.3. Okay, so now we're doing 6.3, right? So 6.3, they're saying consider the function g of x is equal to 4 minus 8 sine squared x all over 3. So they want us to think about this thing, this function over here. So they're saying calculate the maximum value of g. They want us to find the maximum value of g. So they want the highest value of g, right? So what is g? G of x is equal to 4 over 3, right? Minus 8 sine squared x all over 3. That's what you have. So if you look at this, the g of x is equal to 4 over 3 minus 8 sine x. This is sine x all squared all over 3. So it's more like what you have there is a square of this function, because this function here that I've drawn is sine of x. So this is a square of this function. So what does this mean? So if you have sine x all squared, this thing is always positive. Just this thing on its own is always positive. So this thing, sorry, not positive, it's non-negative. It's not positive, non-negative. Positive means it's above 0. Non-negative is 0 or more. I'm correcting that statement. So this thing is always non-negative. Right? So which means if I plot this graph, it will always be 0 or more than 0. It will never go below 0 like that of sine x. So if I were to plot it, I would think it would look something like this. It will turn that 1, it would go down to that 0. When it gets there, instead of going down, I think it would go up again and come down like this. So the black one is your sine x. I'll say your g, which is this function. Sorry, not g. That function, sine squared x. I think your sine squared x or your sine x all squared will look like this. Here. So this is 1, of course. This is 1. Or maybe it's too high. So let me make it 10 somewhere, because 2 should 10 at 1. So I'll make it look like this over there. So your y value is equal to 1 all over. So I think if you were to draw this function, it will look something like this. It would go up, down, 10 there. Maybe let's make it 10 like a parabola. I don't know. Something like this. So this right function is this. This black function is sine x. So what you have here, you know that this thing is non-negative, is 0 or above 0. Right? So this will be 0 or it will be above 0. It will not be less than 0 because you squared all the time. Fine. Now, if you want the maximum value of this, you want the highest possible value. You know, look at it here, the red function. It's between 0 and 1. It takes y values that are from 0 to 1. So use the y values that are from 0 to 1 over here. The red function. So now the values of these things either 0 or above 0. Right? So look now. If this is 0, the entire part will be 0. If your sine squared of x is 0 here, if you put your 0 here, this entire part will be 0. Right? And your answer to this will be equal to what? It will be equal to 4 over 3. If your sine of x, which means think of this position and that position over there. If this part is 0, this entire part will be 0 because it will be 0 times 8 all over 3. This part is 0. So it will be 4 minus 0. It will be 4 over 3 minus this 0 that will be here. So your answer will be 4 over 3. But think now, if this is not 0, it will be above 0. If this is not 0, it can be anywhere above 0, anywhere on this interval. Not these 3 points that are sitting at 0 there. So now, if it is above 0, that means this part will be positive. This minus a positive number will be smaller than this. We'll be reducing this number over here. So in order to get the maximum value of this part must be 0. Which means you get the maximum at 0, at 180, and 360. That's how you get your maximum. You get it what? At 0, 180, and 360 over there. So, if now your value here is above 0, which is the entire thing. Actually, if this thing is above 0, now you will be saying 4 over 3 minus something that is not 0. Right? Which will make your answer to be smaller than your 4 over 3. But if it is 0 sitting at this point, then your answer will be 4 over 3. So in my case, we are going to get a maximum value when we are subtracting nothing from 4 over 3. In that case, we'll say the maximum of G is equal to 4 over 3. That's how I'll do it, in my opinion. Because if you're subtracting, if this is 0, then your answer will be 4 over 3. But if this is not 0, then in that case, now you'll be subtracting the value that will be here from 4 over 3, making 4 over 3 smaller than 4 over 3. Actually, making your answer smaller than 4 over 3. That's what I'm trying to say. So, I'm done with 6.3.1. Go to 6.3.2. So we did give a thought about that, because when they're saying causes of function, they wanted to think about that function. So we thought about it. So yeah. So they're saying now, write down the smallest possible value of x for which g will have a maximum value on the interval. So they want us to find the values of x where the maximum, where we're going to get 4 over 3. We said we're going to get 4 over 3 when the square of sine, when this sine squared of x is equal to 0. Sine squared of x is equal to 0 where? Here, here, and there. 0 at 0, 180, and 360. So they want us to write the smallest possible value of x for which g will have a maximum value on the interval. So we said that we'll have a maximum when sine squared of x is 0, which will actually happen there, there, and there. But they want the values of x that are where? That are between 0 and 360, which is 0 and 360 are excluded. So in that case, we're left with what? We're left with 180 degrees. Actually, 360 is not included, so 360 is excluded. So, but the smallest on my graph is 0, followed by this and that. But if 0 is excluded, the next one should be 180, in my opinion. Right? And I hope this question does make sense to you, as it does to me. Thank you for watching. We're done here. Thank you. Cheers.